Hey everyone, hopefully I am now live. If I could get anyone that's in the chat just to give me a thumbs up or a yes to say that we're good. I think I'm running about 5 or 10 seconds behind, so okay. Thank you very much. So firstly, welcome and thank you for attending our Spring 2022 live stream. Obviously, all of the content will be available afterwards, and we'll be cutting up each of the sections, or each of the sessions, I should say, into individual chunks, as well as keeping the whole event in as one as well. But the reason why we wanted to do this was because it was back in the very beginning of December 2021 where we last met. We were actually in person at AWS reInvent, a co-located event where we had some great speakers, some great panels in an awesome location that we were also able to live stream, and we've had some great viewership around the content that we actually made there and the content. But we also wanted to raise awareness of the community and what we're doing here with Cloud Native Data Management Days and everything data and storage and everything in between, because we've got a pretty packed schedule coming up for at least the first half of 2022, where firstly, we had this and we've got some amazing speakers coming up. But also, secondly, we've got the KubeCon co-located event as well, where call for papers are still open, and expect to have an in-person event in Valencia with a packed timetable and an agenda covering all things data and storage and everything in between there as well. The other area as well, we've also booked into We Are Developers, which is a conference that 2 years ago saw many thousands of different developers, of which obviously includes DevOps engineers and operations folks as well, in that we're going to have a 2-hour stand there. So the call for papers is also extended to that. So if you're going to be in Berlin, then by all means, drop us a call for papers, and we'd love to have you either on a panel or submitting a session there as well. But let's get into what's happening here today. So if I jump over to these slides, hopefully you can still see these. But first of all, again, a big warm welcome, whether you're watching live or whether you're watching a repeat. I would ask that if there's any questions, post them in the chat. I will come at the end of each session and speak to the speakers and raise those questions that you have. If you are watching after the fact, then obviously there's a comment section down below that you can add your questions in. So just to touch on some of the areas that we're going to be focused on in this session before handing over to Bhavin for his first session, is that Bhavin's going to very much talk about point of failure from a data protection or data management point of view. So what is or how to avoid that single point of failure within a particular EKS cluster. But I'm actually sure that will span across any Kubernetes cluster for that matter. So then an interesting take from Tim Myers and Geoff Burke, where they come from, dare I say, the more traditional landscape of virtual machines. But as we're seeing this large wave of infrastructure and operations teams having to look after Kubernetes environments and having to look after the cloud native application now, and now looking at how we backed up virtual machines and physical computers for however long, and now we're going to have to look after containers. So that'll be an interesting take and story that way. And then, like I say, going from data to storage, we start looking at big data from a data lake experience point of view, looking at object storage in particular around being able to where you're going to store that data, that mission critical data from a production point of view. And then we're going to have a panel discussion from our analyst sponsor evaluator group, where they're going to give us a state of the state around IT adoption and containers and some of the perspectives that they're seeing within their research. Then we get to go and look into another area around data science, so a very broad topic when it comes to data management. It doesn't just mean data protection. It also means data governance. It means different storage layers. It means also how we're using data science. And we've got Audrey and Troy from Red Hat to come in and speak about what they're doing from an OpenShift point of view. and then around about past the hour at that point, we'll be closing that down and then answering any of the questions along the way. So without further ado, let's hand it over to Bhavin, and let's bring Bhavin in. Hey Bhavin, how's it going?
Hey Michael, excited to be on another Cloud Native Data Management Day session here, and thank you for kicking us off. I was just logging into my AWS portal, and once that's done, I can share my screen and we can get started.
Sorry, I put you on the spot for a live demo.
So
but yeah, you're becoming quite a regular, right? In the Cloud Native Data Management Day, I think. So we started off again in KubeCon EU 2021. So that was an all virtual affair, and then we pivoted round to KubeCon NA, and then did the virtual or the live stream and in-person event at AWS. And I know you were there for at least two of them, but I expect you were probably there for the first one as well.
Yeah, I was there for the last two ones, so like KubeCon NA and then AWS reInvent, and like doing virtual sessions. So this is always fun. Unfortunately, I won't be able to make it to KubeCon EMEA in Valencia, but yeah, other than that, I'm looking forward to participating in the community. I'll be a spectator in that event, I guess.
Good stuff. Same here. I won't be there either, but we will be represented, I'm sure. So, Bhavin, without further ado, I'll hand this over. I'll keep an eye out on for any questions, but I'll be back in a bit.
Okay, thanks, Michael. So, good morning and good afternoon, everyone, and thanks for joining this live stream. Today, we are here to talk about how you can avoid any single point of failures when you are running containerized applications or your containers on your Amazon EKS clusters. And again, as Michael hinted in the introduction, this can apply to any other Kubernetes distribution as well. But today, specifically, we are talking about Amazon EKS and the AWS ecosystem. My name is Bhavin Shah, and I'm a technical marketing manager with the Cloud Native business unit at Pure Storage, or the Portworx business unit. I've been here for more than a year now, and it's always fun to talk about Kubernetes and Kubernetes storage. The plan for today is I just have one slide before we jump into the demo section. So this will be a demo-focused session. But as a backup, since we are doing multiple live demos, I do have a video recorded demo of the whole workflow. So if at any point I run against the quota of the number of load balancers I can provision, which is something I hit yesterday, I'll switch over to the video section, which I recorded yesterday, and then we can like see how to do certain things, maybe not live. So let's hope everything works out. And this is that one slide. So talking about containers and how you can run them on your EKS clusters, there are a few gotchas or single point of failures that you need to keep track of. The first one is around node failures or availability zone failures, which again are not as frequent, but they do happen. So you need to plan for that as an organization. And to counter against those kinds of failures, you need to have local high availability in your Kubernetes storage or your Kubernetes cluster itself. So your persistent volumes, we'll talk about how in using Portworx, you can have persistent volumes that store replicas across your different nodes in the same EKS cluster. So even if a single node goes down, even if an entire availability zone goes down, Kubernetes will respawn the pod on a different node in your cluster. And because of the storage layer, you will get access to the persistent volume. So there is no data loss. Your application might be offline if you don't have multiple pods for the same application running on your cluster. But as soon as the pod is up and running, your application can continue writing data and serving customer traffic. That's local HA. Next step up is you want to protect against cluster failures or region failures. And this is where you should store backups, right? Not just of your persistent volumes, but all of the different Kubernetes components. And if we look at the previous sessions that we have done, we talk about how backing up containerized applications is different from backing up just virtual machine-based applications. So we'll look at a solution around how you can back up your application, store it in an S3 bucket, store those backup snapshots in an S3 bucket, and then restore them to a secondary cluster as and when needed. And then if you want additional, if you want to meet those additional SLAs in terms of zero RPO or zero recovery point objective or really low recovery point objective, and a really low recovery time objective or RTO, that's when you add that next tier or disaster recovery solution. So we look at today, especially, we look at an asynchronous DR solution where we have 2 EKS clusters. One of them is running in the US East 1 region. Another one is running in the US West 2 region. So you get that geographical availability. So even if your cluster goes down or if your region goes down, US East 1, we all know, is kind of inclined to like fail every once in a while just to keep everybody on their toes. So we'll see how you can activate basically DR migrations and bring your applications back online on the secondary cluster. So as I promised, like that's the only slide. Okay, so 2 slides if we count this demo slide, but let's switch to a terminal session and look at the Kubernetes clusters that we have today. So we have 2 clusters for the demo. We have a site A cluster that's running in US East 1. So if we do a kubectl get nodes, you see we have a 5-node EKS cluster, which is these worker nodes are split across multiple availability zones themselves. And then we have Portworx installed as part of this to provide that block and file Kubernetes storage for your containerized applications. We have different namespaces. So for each tier of the application, there are different levels of data protection strategies that are needed. So again, if you're an organization thinking about data protection for Kubernetes, each you might have to categorize your applications in different tiers and then perform a cost versus availability analysis around how much do you want to invest and to make sure your applications are online. And then you might have some applications that can't suffer any downtime at all. And then some applications that tier 2 applications can take a hit of around like a couple of hours, and then a similar couple of hours for the time to recover. And then tier 3 applications are test dev applications. Even if they are down for a day, or even if they lose a day worth of data, that's not going to be like the end of your organization or end of your business. So once you have those different tiers of applications, you can build data protection solutions or disaster recovery solutions for them. So today we have 3 namespaces defined for each tier. Let's apply our tier 1 application. It's a simple Postgres application or a Postgres instance with a pgbench load generation tool. So if we apply that against tier 1, and then if we do we deployed the persistent volumes, let's deploy the app itself or the Postgres pod itself. And then while that's happening, let's look at the storage classes that I have, or that my Postgres instance will use as the backend storage. So we have a few storage classes defined because we have installed Portworx. And the default storage class is something called pxdb. And if we do a describe on that storage class, we'll see that we have like a different IO profile set, which understands how the database is writing data to the storage layer. But then we also have a replication factor defined. So REPL of 3 means that you have 3 copies of the persistent volume stored across your EKS clusters. In this case, 3 copies will be stored across the 5 EKS worker nodes that I have in my EKS cluster. So let's see how our application deployment is going. And okay, so my pgbench or Postgres pod with a pgbench container in it is up and running. If we do a kubectl logs, and then let's just tail it of this particular pod, and then specifically look at the pgbench container, you'll see that I have it set so that it's continuously creating new databases and writing data to the Postgres instance, and it keeps going. So our goal is to make sure that we don't lose any databases and our application isn't down for a long time if a node failure happens. So let's exec into the Postgres pod. And do a tier 1. We'll just open an interactive bash session. So I should know how to type better. kubectl, like I said. Okay, now we are in the Postgres pod. We can use the pSQL utility. Log in as the pgbench user. Then if we just do a /l, you'll see a bunch of databases being created for us. Right now we are at like the 51 or close to 50 databases mark if you ignore a couple of rows for templates. So that's what our application looks like. Let's exit out of this pod, and then let's exec into one of the Portworx pod to look at the additional details for our persistent volume. So let me just copy the name of a specific Portworx pod and then exec into it as well. At this point, we can use the pixie-cuttle stat utility and then do a volume list. Here it will show you a list of all the different volumes that you have. So our Postgres instance was 50 gigs in size. So let's grab the volume ID for that row. And then if we can just use volume inspect. And here you can see that this volume on the Portworx layer has 3 copies. All 3 copies exist, like those 3 exist on these specific nodes. And then it's attached to our Postgres pod, and the Postgres pod is actually running on 173. So 173 is the node which is hosting my pod and one replica of my application. So at this point, let's switch to our AWS console, and then just I should have and just try to like simulate a failure. So if we do this, and then so we are looking for the node with, I think the IP address was 55.173, and that's it. So this is running in US East 1B. So and at this point we can have US East 1B go down or the node go down. So that's what we are trying to simulate. So let's just terminate the instance. So it takes a few minutes for the node to completely go offline, and then it for EKS to recognize that the node is now offline. So once EKS recognizes that, it looks at all the pods that were running on that node and then spins it up on a different node in the cluster. Because of the way we work with EKS, we'll spin up that, or we'll tell EKS to only spin up the pod on which one of the volume replicas exists, so that as soon as the pod is up, the IO can continue and PG Bench can continue writing and creating new database instances. So let's see. Okay, it's shutting it down. Let's go back to the terminal and then exit out of the Portworx pod, and let's do a kubectl get nodes. Here you can see it's already in like a not ready state. And at this point, we can do a simple shell script. So what it does is it deletes our Postgres pod and then spins it up on a different node that's available in the cluster. And just to make sure that we are not stuck in a pending state because of EKS, it's better to just delete it and then spin up a new instance on a new pod. So it has a sleep command. We can look at the script once this is done. But once the new pod comes online, we'll be able to log into it, exec into it, and look at all the databases. And that means that we never had any data loss, and our application was down only for the amount of time that it took EKS to notice that one of the node has been decommissioned or not available, and then spin up a new instance of the pod on a different node in the same EKS cluster. So once all of that is done, this means that, okay, your application is fault tolerant to a node or AZ level failure, and you can still be up and running as soon as your pod is online. So let's do kubectl get pods in tier 1. So we have a new instance of new PG Bench pod running on a different node, and if we exec into it, we can use psql login as the PG Bench user and do a list. You can see all the different databases that we saw earlier, and much more than that are there. So like we never suffered any data loss or hit any consistency issues with our Postgres instance. So that is like how you can achieve fault tolerance at the node level. Let's switch to the next scenario, which is where we have a different application running in our tier 2 namespace. So for this particular namespace, we have created an asynchronous disaster recovery solution between our US East 1 cluster and our, let me switch to the second tab. This is the US West 2 region. And we have created a cluster pair object. So if we do a kubectl get cluster pair in the tier 2 namespace, you can see we have a trust relationship created between our source and our destination cluster, or our primary and our secondary cluster. At this point, we also have a schedule policy defined. So this is where you can set policies with that get triggered whenever your migrations are triggered. So if we do a describe, you will see that this policy basically, whenever it's attached to a migration schedule, it copies over your data at a 15-minute interval. Again, this is completely user customizable based on the SLAs that you have for your applications. It will take a daily, it will do a daily roundup, a monthly and a weekly as well. So you can define these schedule policies to meet your business level objectives or SLAs. And once you have a schedule policy, the next step is to create a migration schedule. So a migration schedule basically defines what should happen. So this is like a recovery plan that you have. So here you can define things like what's the namespace where your application is running, which is the schedule policy that it should use. So the interval at which the application is moved from, or the application is replicated from our primary to our secondary cluster, and a few additional parameters which define which cluster pair object to use, whether I want to include all resources. So this means that whenever we are migrating or copying over our application, it's copying over not just the persistent volumes, but any and all Kubernetes objects and application configuration that you might have on your primary cluster. And then start applications is false, because since this is an async DR, you don't want this to be an active state. So after the first migration, you don't want your application to be also online on the secondary side. So we set that to false. And then in case of a disaster event, we can log on to our secondary cluster and then just activate migrations, hit a simple command, and it will start bringing up the application. So let's apply this migration schedule. Actually, before we apply that, let's look at what the application is actually. So it's a simple web-based application that I think I already have the tab open. So basically, wherever I click, it generates a new entry, a database entry in the backend database, capturing the pixels, the X and Y coordinates for the pixel where the Kubernetes logo is generated, and it updates the number of database records that I have. So this is my application. Now let's apply the migration schedule. And once it's applied, we basically copy over the persistent volumes first. And then once the persistent volume is moved over, we copy the other remaining Kubernetes objects. So if we can we can use a couple of different commands. So we can do a storkctl get migration schedule in the tier 2 namespace. And that shows what's the progress. A migration schedule basically creates an individual migration object at every interval. So as you can see, we have our first migration that's active right now. It's copying the volumes. It's in progress. We have one volume that's being copied over. If you want to look at additional details in terms of how many bytes have been transferred as part of this migration object, you can do a kubectl describe on the migrations. And here you can get a full detail around like, okay, what's being migrated. It looks like our migration has been completed successfully. So if we do a storkctl get migrations again, you will see that our stage is final, status was successful. It copied over one persistent volume and 7 different Kubernetes objects as part of the migration. Let's go to the secondary cluster in this case. And if we do a kubectl get all in the tier 2 namespace, again, tier 2 namespace did exist, but none of these objects did. So as you can see, 47 seconds ago, these objects were spun up. But one thing to note here is you don't see any Kubernetes pods. Like you see the deployment objects with your replica count set to 0. You see the service objects. If we do a kubectl get PVC, you see the persistent volume already being created. But since we didn't set the start applications flag to true, it was set to false, we don't see any pods. This can be like, let's say a disaster happened, US East 1 went down, or your primary EKS cluster went down. At this point, you can just use one of our commands, storkctl activate migrations, and specifically for the tier 2 namespace. And that's when it already had the metadata of how many pods were part of your deployment. So once you activate the migration, it begins and deploys those pods, or basically increments the number of replicas that you had for your deployment objects and spins it up on your secondary cluster. So if you do a kubectl get all in the tier 2 namespace now, you'll see our pods have started to come up. So both of them are already in the running state. So what we can do is we can copy this load balancer endpoint and navigate to our browser. Hopefully, the ELB is up and all the different instances that are backing it are online. So usually it takes a few seconds for ELB to come online. But as you can see, this was our source site, this first tab. This last tab is our destination site. It's running in US West 2. All the 12 database records showed up, all the different Kubernetes logos showed up. So our application was successfully migrated or failed over from our primary to the secondary site. You can easily fail back when your primary cluster is online, and we'll sync the data at the first migration, and then you can do a similar activate migrations on the primary site as well. So that was the second demo. Let's look at the third scenario. And for this, we have another namespace and another application deployed for you. So here you can see we have a simple WordPress app running in the tier 3 namespace. And since this organization only publishes one new blog every day, it can sustain some data loss. It's not a really critical site. So it doesn't need a disaster recovery solution. It can just get by using a data protection solution where any blog posts that are published, it has an SLA of 24 hours. So you can recover from failures and still not have any data loss in many cases. So it's a simple WordPress site, a cloud native data management, and then we have a blog post that was written as well yesterday. If we go to our PX backup UI, which is what we'll use to perform Kubernetes backup and restore for our application, we already have our AWS accounts added. So you have our AWS account and an S3 backup repository that is used to store your backup snapshots. And if we go to our site A cluster and look at the backups tab, I already have a backup running every hour, which basically protects the WordPress site. And again, you can customize these as part of your schedule policies that you define in PX backup as well. And when you log into PX backup, you can look at, once you select a cluster, you will see all the different namespaces that you have configured. So our application is running in tier 3. We can create an ad hoc backup job. So let's just do a demo backup. You can select a backup location. Since we only have one, you can select that. You can create a one-time backup job, or you can do this on a schedule. So your backup admin or DevOps admin can go ahead and pre-create these schedules for you if you are the application owner. And you can select whether you want an hourly backup, a daily backup, every 4 hours, every 8 hours. And then since I already have an hourly going, I'll just do an ad hoc or right now backup. And then I can also, to make these application consistent, I can also specify pre and post exec rules. Once I hit create, PX backup will talk to your site A cluster and then start backing up not just the persistent volumes. So let's look at all the different resources that we have, right? So we have a couple of deployments, a couple of replica sets, a couple of pods, services. If we do a kubectl get PVC, it also has a couple of persistent volumes as part of the WordPress deployment. So PX backup will talk to the namespace, identify all of these objects, and then protect them and store it in an S3 repository. As you can see, it took a while, a few seconds, since it's a small footprint application, and successfully completed that backup job. So if you do a show details, you can see we have those persistent volumes, deployment objects, service objects, and there was also a MySQL secret as part of the namespace. So all of those were protected. And you can use this UI to monitor how your backup jobs are doing. So you can look at the last 24 hours, and then you can also zoom out and look at the last 30 days. I've only had this instance running for the past 2 days, so that's why you only see 2 days worth of entries. But now that you have an application that's backed up, you can select to, you can choose to restore it. So let's hit restore, and then Let's do a restore on the second cluster. Again, for this demo, I'm just using the same cluster and I've already added to it. But using a data protection tool allows you to not have a secondary standby cluster all the time. In case of a disaster, you can spin something up quickly using EKS, CTL, and then just add it to PX backup and perform a restore operation for your application. You can perform custom restore. So you can select the namespace in which you want to restore this specific application. You can select what objects inside the backup job you want to restore. And then just once you have decided or customized all of that, just hit restore, and PX backup will initiate the restore job for your Kubernetes application. So let's go to the secondary cluster and then do a kubectl get all in the tier 3 namespace. And it takes we follow the same thing where we copy or restore the volume first. So let's do a watch command on this end. So whenever the backup job is completed, those resources will start showing up. So as you can see, we have our deployments, our containers are in creating, our pods are in creating state. We did get lucky, and I didn't hit the ELB quota for the live demo. So it looks like we also have an endpoint going for us. So once the containers are up and running, we can basically navigate to that endpoint using our browser and validate that our WordPress site is back up and running. So let's exit out of the watch command. Let's look at the persistent volumes in tier 3. So you can see we have both of those PVCs that existed on the source site now exist on the destination site as well. And then if I just do a kubectl get all, you can see both of our pods are now in a running state. Let's copy this endpoint and let's hope our ELB is up and running and we can. Okay, so it does take a time. We got lucky with the tier 2 demo. Tier 3, I guess we'll have to wait a while. But I guess while we are waiting for WordPress to come up, let's switch to the site. So today we looked at like 3-4 different parts of the Portworx portfolio. But again, for people that want to learn more about Portworx can join Portworx webinars. But this is just to show how you can have a solution at your Kubernetes storage layer that can help you build fault tolerance to not just node level, but also cluster level, region availability zone level, or even a cloud level for that matter, and help you move your applications where you want them to be. Again, I won't spend much time on this, but you can find me and find other demos that we have around the whole portfolio. So now if we refresh the page, we see that our WordPress site is back up and running. Our post from yesterday is there. So basically we restored our application from our primary cluster to a brand new secondary cluster. But I guess that's all the demos we had for you today. And Michael, do we have any questions? If not, I can cede my time here.
So I had a question in regards to how many ELBs per region can you actually have?
Oh, it was like a really big number. And I don't know, yesterday when I was testing the workflow, I was like, damn it, this shouldn't happen. So that's why last night I was recording a 30-minute long video just to make sure I have something that I can play for the audience.
Good stuff. And then the second question, again, this was from me. The cluster pair, when you obviously deploying the software into the cluster, is that an API service or an API resource that gets pushed into the Kubernetes cluster?
Yeah, so let me show you the YAML file for it, right? So it's a simple it's a Kubernetes object called cluster pair, and it establishes a trust object between your primary and your secondary cluster. And you basically generate that on your destination site. So you take the cluster token, the IP address for your destination site, and create the specification. But then you apply it against your source cluster. So if you do a stalk serial get cluster pair, you'll see that we sync at the storage layer and the scheduler level as well. So that's why we are able to copy not just the Kubernetes objects, but also persistent volumes. For synchronous DR, there is a requirement of less than 10 millisecond round trip latency, because that in those sync DR cases, we are basically deploying a stretched Portworx cluster. So you won't see like a storage status. We just sync the schedulers between the two cluster, and storage replication is handled by Portworx under the covers.
Yeah, you still need the laws of physics still remain, right?
Yep.
I think that's the important part for any of us talking about data management, data protection, is that Kubernetes is as another platform. It's the same but different to maybe where you've been protecting workloads from virtual machines and physical. And I don't want to steal too much of Tim and Geoff's thunder in the next session, but it's a purpose-built solution for Kubernetes is kind of where Bhavin was going from that point of view. But awesome session. Love a live demo. Glad you were able to do a live demo and didn't have to use a video, Bhavin. Yeah, awesome session. Thank you very much.
Thank you.
I'll just drop things down. Cheers, Bhavin. Okay, so now we're going to bring in Geoff and Tim into the stream. If you want to share your screen as well, I assume it's Geoff.
Yep.
Yep.
Where we're going to get a bit of a history lesson, I think, in terms of protecting workloads. Just the story. In fact, it'd be awesome as well, Geoff, if you start off with, and you, Tim, as well, just a bit of your background, because like me, I feel like we come from the operations side, the infrastructure side, and I think that plays a huge part as to what we're seeing from an adoption rate into this world. So I'll hand it over to you. I'll come back on when you're finished, and hopefully we've got some questions for you at the end. So over to you guys.
Yeah,
Okay.
Mike, thanks. Appreciate it. I mean, I'll go first, then I'll turn it over to Geoff. So my name is Tim Myers, and I am the Chief Technology Officer for Sunati. And I'm joined today by Geoff Burke, who's our Senior Cloud Solutions Architect. And, Mike, just to touch a little bit, to your point on background, I was an early VMware employee back in the day. Let's call it, 2003. VMware was about 700 employees. Virtualization was really kind of coming along. People were deploying it very rapidly in test dev environments and immediately jumping through to production. I really saw kind of the advent of this multi-tenant virtual machine workload infrastructure crop up, the ecosystem that VMware created. I was very fortunate to kind of be part of that. And one of the things that we want to really talk about today is what does that journey kind of look like over the years, right? For the person that's looking at the traditional legacy server, right? The physical server, then they had the responsibility of building a data protection strategy around virtual machines. And now all of a sudden, this thing called containers is here front and center, staring us in the face. And, there's this whole ecosystem that's been built around that, right? So we're gonna tell this story and hopefully, give you guys some kind of takeaways. Geoff, why don't you go ahead and introduce yourself there, bud?
Sure. So my name is Geoff Burke. I'm the Senior Cloud Solutions Architect at Sunati. I am certified in the Kubernetes field CKA, CKD, CKS, KCNA. I'm also a Veeam certified architect and Veeam certified engineer. And I'm a Veeam Vanguard, Veeam Legend, and just recently a Calico Big Cat ambassador. So that's me.
Wow. You're a pretty important guy, Geoff.
That's the titles,
Pretty important guy. Okay, so if we jump into the next slide,
Sure.
Let's tell a little bit of this story, right? This all started back in the day with what we'll now consider legacy, right? Everything that's old moves into this kind of combination field of called legacy. But in the world of legacy backup physical servers, there were things that we kind of understood back then and kind of maybe snarl our nose up a little bit at today, right? The first thing that we had to do is we had to install a software agent on that physical server. That was really the only way that we could do that backup. We did backups with these big, huge honking tape libraries. And there were people that were changing tapes every night. And tape is still prevalent today, but this was really the only mechanism that was kind of tried and true back in the day. The challenge with that is that anytime that you needed to do a restore, well, the restore was slow, right? As Mike mentioned in the earlier session, we had the laws of physics. So how big was the data that was being backed up? How fast was the speed of the tape drive? Did you have multiple tapes, multiple tape drives in a library? What was it being restored to, the medium types? All of those types of things. And when you think about the idea of using that infrastructure as part of your disaster recovery scenario, well, that attributed to long RTOs. So, people would back up every night. You would always kind of, be a little timid around the restore. I can remember, and I hate to show age, but I can remember back in the day where, you would get restores that would get to 98% and you get CRC errors on the tape. It was always kind of hit or miss there, right? We looked at the only real way to do any type of recovery as being a bare metal recovery. Again, another one of those terms that came about later in life as we talked about the difference between doing maybe a virtual machine restore versus a physical machine restore. And the problem with doing a bare metal recovery is that, well, the servers were different. We had to inject drivers. There was always unknown items in, device manager, if it was Windows, or, identifying the Ethernet driver, or, all of those types of things, right? So it involved this driver injection from a floppy or a CD-ROM drive. At the same time, though, if you had to look on the bright side, before we coined this term, putting all of your eggs in one basket, or server consolidation, or what have you, if you did lose a server, a physical server, chances are way back then, you were only losing one application. So if we move on to the next slide, Geoff, right? So then we jump into this idea of along comes VMware and the advent of virtual machines. So VMware introduced this thing called the hypervisor, and the idea of being able to virtualize these workloads and having just a whole new breadth and depth of open possibilities in the way that you could manage this infrastructure. It also allowed for things like faster recovery. Now, that meant that the data protection solution that you were using had to have some knowledge of a hypervisor, the understanding of the components of a virtual machine. And what that really kind of, evolved to is that these people began this P2V transformation. They realized that there was a huge benefit in being able to have these infrastructure workloads deployed as virtual machines. They could be deployed, they could be moved from like a vMotion perspective, if we're talking about VMware terminology. And then the migration happened as people began that physical to virtual migration. It also caused an evolution in the data protection strategy. Now I need to be able to have physical machines that are still being backed up with those agents. I need to be hypervisor aware, because what I really didn't want to do is still have to install agents in every single one of my virtual machines, because every single one of those agents had a penalty, right? There was a performance penalty. Let's call it, a percentage of performance capacity that was being used that would then cause you to have to, do some math, right? From a consolidation perspective, and figure out, if I've got 25 virtual machines that are all running on one machine, and I've got those agents that are installed in every single one of those virtual machines, well, I'm losing my ability to do that server consolidation because I've used such a large piece of that performance workload just from those individual agents. And so when we come to the virtual machines, well, you know what? That backup process did have to change, because now we need to be virtual machine aware. We need to understand what was a VMX file or what was a VMDK, and what were the important components of a virtual machine that needed to be backed up, and how do I restore those? So you can see this evolution happening as we move from the idea of installing agents in the old legacy physical servers to now being more hypervisor aware from a backup protection standpoint, and being able to leverage that native hypervisor backup functionality just to kind of make things easier and simpler. So physical servers, virtual machines, and Geoff, then came containers, right?
Exactly.
So we move on to this next slide, and we now really kind of get into this containers and the container orchestration with Kubernetes. And why don't you kind of walk us through this piece?
Yeah, so that was excellent, Tim. Basically, stressing here the evolution and the change which is necessary, because I have to admit, when virtualization came about, I didn't really understand that this was changing, and I continued to use agents for a while, and I paid for that. So it's very important. Now, with containers, they've actually been around for a long time. It was in 2014 that Docker I might want to say, brought them to the masses. They'd existed before then. And the thing about containers is you're going to get a lot more of them because they're smaller, they take up less resources. So obviously the question came up is, how do we control them? And how do we deal with them? And this was already seen with hypervisors, because in effect, hypervisors are also orchestrators. If you have huge data centers in VMware and a lot of VMs, without vCenter, it would be nightmare, or Hyper-V failover cluster manager. Same thing here, but exaggerated. And so there were a few different types at first. Docker still has Docker Swarm, for instance, but now it's pretty much accepted that Kubernetes is the orchestrator de facto. The other thing when it comes to backup was, and I had a question I asked somebody from a backup company back in 2018, are you going to support backing up containers? And the answer was, well, why back them up? They're stateless. Because a lot of these containers before would be things like static web servers. So, the container would die, bring it back up, there's no change. That has also changed. Now we have a lot of persistent volumes. And persistent volumes means that there's data on disk and it has to be protected. Okay, so we've talked about the orchestrator, stateful containers and deployments. And the first thought, again, if you're in a legacy mindset, well, okay, I'll just use an agent, a Linux agent, or if my Kubernetes nodes are in like vSphere or something, I'll just use the VM backup tool I was using. But that's a similar situation to the people who continue to use agents in VMware. You're missing out on a lot of the new features, and you're not using a native backup application. When I mean native, it means it's been specifically written to use and leverage all the new functions that are available. So native backup and recovery is essential. Then, of course, the question comes, okay, native backup. Well, what, how, and where? And this is important because what are we backing up? Obviously, we're backing up the persistent storage. That goes without saying. But there's something more with Kubernetes. And if any of you have ever dealt with vCloud Director, you might understand this better. vCloud Director had a concept called VApp. And it was a bunch of VMs which were inside a VApp. And when you were backing that up, you would not just back up the VMs, you would back up the metadata around those VApps. Because when it came time to restore it exactly the way it was, you need that metadata. So here we have a similar situation. We have our storage, our stored data, but we have also all sorts of components in Kubernetes. On top of that, we have something in most Kubernetes distributions that are big, etcd, which is the brains of the cluster. So that has to be backed up. Similar to vCenter is backed up now. VMware finally created a scheduled backup in vSphere. Same thing here. You want to back up the brains of your Kubernetes cluster. Persistent storage, we've talked about that. It's obvious. But there are these things, these components, config maps, secrets. These are things that are essential for your Kubernetes deployment. So for instance, you might have a MySQL database, and that requires a secret, so a password for the database. And you could make a mistake and delete that secret, or you could corrupt it. So you have to back up all these extra components. It's very important that you pick a backup solution that does this. So every component you want to back up in your deployment. Very important as well, and this goes against the idea of using a legacy type of backup, is you want to be able to granularly restore these items. So if I, by accident, go into a config map and I make a change and it's become corrupted, I don't want to have to restore my entire deployment. Downtime, it's a waste. I want to be able to restore just that config map. So it's important, again, that you find a backup solution which is going to leverage native Kubernetes backups. Basically, on the native idea, again, there's even a very good example is Azure. I used to back up Azure before there were Azure snapshots using an agent. So we put an agent inside the Azure VM and treat it like a physical server. Restores were slow. It wasn't efficient. Microsoft came out with Azure snapshots. We started using Azure snapshots. And Veeam, for instance, came out with an Azure appliance. Very efficient, very quick, native. So it's the same concept here. Okay. Important question here is, if you're a backup person, you've worked for many, many years like I have, how do you stay relevant? Things are constantly changing. And this is a big change. The one thing you want to do is remember, it is a steep learning curve, but don't look at Kubernetes from afar. It reminds me of those little mosaics. You see ancient Greece or ancient Rome, those big mosaics paintings. And from afar, oh my goodness, this looks so complicated. You want to go and start slow. So take it one step at a time. It gets easier all along. Also, a big advantage of Kubernetes is you can really play with these technologies. So I can load onto my laptop Minikube or OpenShift's container-ready containers, Tanzu Community Edition, and I can mimic a production environment much better than ever before with VMware Workstation or something like that, trying to mimic an entire vCenter. So that it is a learning curve, but you now can do this on your laptop. You can do it much smaller resource. You don't need them. On top of that, there are a lot of free resources out there. There are learning sites. Kasten has a learning site. Tanzu, Kubernetes Academy with VMware. So, and OpenShift has some too. So it's out there. You can just Google free Kasten learning. You don't necessarily have to spend any money. So that's how you stay relevant. I would start now. Don't put it off. I am at my 2-year stage. I've gotten all the certifications. I still feel like a beginner because it's big, it's enormous, but it's a lot of fun. Okay, so at this point, I wanted to go to a short demo to display some of the differences. And Tim can help me out too with this to show, we can talk about some of the legacy things, which aren't legacy anymore. Don't get me wrong, VMs are probably not going away. We still have physical servers as well. The difference is there'll be a shift over slowly but surely more to one area. So let's bring this up.
Yeah. So Geoff, while you're doing that, right? So just a couple things, and I think from the audience's perspective, there's two things that I hear, right? Number one is it's not been a 100% lift and shift methodology that's occurred here, right? In the professional services and operational arena that we live in every day, there's still physical servers that exist. Some of them can't be virtualized. There's this idea of digital transformation that's happening where people are aggressively looking at their existing installed applications, right? Let's call them legacy potentially. And they're realizing the benefits of Kubernetes orchestration. They're understanding the benefits of the transient workload and the ability to create and maintain these persistent volumes. And that's a very different opportunity than maybe what they've had previously. It sounds very similar to this idea of virtual machines, but it's a very different architecture. It's a very different consideration. And so what I think is important for everyone is to realize that the same way we talk about cloud as being a hybrid cloud, the chances are in your digital transformation journey, most of the people that we interact with are in this hybrid stage. They still have physical legacy servers that they have to maintain and back up and protect. They have a good portion of virtual machines that are in a multitude of locations, whether they're private, managed, on-premises, hyperscale, public cloud, right? Multiple locations and technologies. And then they're also now doing this true application transformation as they move from the archaic, monolithic application to now into this more cloud native application space. And I think that part of that is to realize that it's always going to be moving. It's going to be evolutionary. And so what we tend to talk about is what is the easiest way to manage and maintain and evolve your data protection strategy that can kind of move alongside of the customer journey or the application lifecycle journey that your business is moving, right? So Geoff, you've put together this demo for us. And I think if I remember correctly, you're going to be able to show us how we can kind of do that, right? We can back up these multiple types of applications that, our legacy do require agents, could be in the public cloud, could be traditional virtual machines, and then also this cool ability to be able to use a cloud native solution for Kubernetes as well, right?
Yeah, exactly. And that's one of the challenges, I think, if you're a backup administrator, is there's going to be a time where you're going to have a lot of these different technologies. And we're always going to have physical servers and we're always going to have VMs. It'll probably shift somewhat. So important, at least from my perspective, is to have something or choose an application which can make it easier. So you don't have to have 15 different applications. I mean, you don't want 20 antiviruses, right? Same kind of thing. So what I've got here, I don't know how well you can see this. Is it too small? But this is a Veeam installation. And what I first wanted to just show was a traditional VM backup. So here's a Windows VM. And we would attach from Veeam to the hypervisor here, being VMware, the vCenter, and I can go in there and create backup jobs. So this would talk to vCenter, communicate with it, grab the information it needs, and then create a backup. So that's your traditional VM backup. You can also use an agent, which will also go into here. I don't actually have one installed right now, but it's the same kind of idea. And restores can be done by very simply right-clicking, and it gives you, again, from this new, well, used to be new hypervisor point of view, all these options: instant recovery, instant restore, disk recovery, restore entire VM, guest files, Active Directory. So wonderful. So ideally, going forward, we want something similar. We don't want to get less. We want to get more. So what's happened now, at least with Veeam and Kasten, is that there's some integrations taking place, and it's going to get more and more integrated as we go along. This is the Veeam server, but what I also have here is, if I can just find it, oh, I'm in the same VM, a Kasten deployment. And it is web-based, and I will show you how it's connected up to the Veeam server. So first of all, what is my Veeam that I've got, my Kubernetes that I've got here? Well, I've been playing with Tanzu Community Edition. Again, free. And I'm just starting Tanzu, by the way. I've been doing a lot of traditional Kubernetes, so I don't know it inside out. I do know that they have what they call a management cluster, and you're supposed to have workload clusters, but hey, it's a lab. I'm just playing around, having fun, same thing as you guys can do. So what do I have? I got my little Tanzu here, and I've got a bunch of namespaces. And Tanzu has its own, and I don't really understand them fully yet, Tanzu system, Tanzu package. What I've done is I've created an Nginx namespace right here. And so I have a pod running there. So I'm using alias too. That's why I'm using K and not kubectl. So I will go in there and take a look and see if it's running. Hopefully, yes, it is. Okay, so what do I have? This is a basic, small, very simple website, which I've got running, and I've exposed it to the world. And I can actually show it to you. Now, I am not a HTML programming genius. And so you will see that my website is very, very simple. So it's, hi, this is Geoff. There you go. I haven't gone too far lengths at that. But what can I do? Well, so that's running and that's live. What I can do right now, if I want to, is I can actually change that. So I will go into the pod. I'm just going to be lazy and go backwards. And then I'm going to go to the location where Nginx keeps this. And I think it's HTML. This location inside the pod is a persistent volume claim. This is persistent storage. So the pod is running, the container is running. It's got its all system in there, but there's one location which is persistent, and it's this one. So if we look in there, we will see a file called HTML index. And if we cat, we will see, hi, this is Geoff. Okay. So what if I think that's just too mundane and I want to make it a little bit interesting? I will change this to Geoff is great. You know, why not? Okay, now let's go back to our website, if I can find it somewhere here. And what we should see right away is, if I can get, there we go. Let's refresh that, and guess what? Geoff is great. I like that a lot more. But let's say my boss, Tim, comes along and says, Geoff, you know, that's a bit arrogant. I don't like that. And what if I can't remember how to get into that pod? Well, I better have a backup, which I do, so I can restore that and not get fired. So here's my Kasten right here. And what I like about Kasten is it's at a glance. Now, I talked earlier about how Kubernetes is so difficult, how complicated to some extent. Well, what you don't want then is a backup application, which is complicated. You've got enough to learn as it is. So what I like about this, I've actually shown this to salespeople, and they've been able to figure things out. And I don't want to get, you know, mean towards salespeople, but generally, if I show them the Kubernetes command line and say, okay, do a backup of etcd, that's it. They're gone to lunch. They actually figured this out and they liked it. So that was good. And it's good too, because if you're a service provider out there or you're providing any kind of service, you want your customers to be comfortable, and your customers maybe don't have time to learn something inside out. So that's an important factor. Anyway, so here I can go to unmanaged applications, and they're all there. And this is namespaces, okay? So I can look for my namespace, Nginx. That's next page. There's a lot of them here. And well, I must have missed it. It's in there somewhere. Oh, you know why it's not there? Because I've already created the backup. Sorry. So that's the beautiful thing. If you create a new application and you've forgotten to create a backup, it'll be there. But if you've already been a good backup person that I am, it'll be in the compliance area right here. There it is, Nginx. Okay, so if we open this up, well, first of all, why don't we restore so I don't get fired? So here's our restores. And very simple, very explanatory. So I did a backup yesterday on Monday, and the backup is comprised of two components, which is very important here. And here's another difference. Remember, this application, and it's Kasten in this case, it could be something else, is running on that cluster. And it's taking a snapshot of the data on that cluster. Well, what does that mean? If that cluster dies or the hardware dies, you've lost everything. So that's the first step for quick restores. But you must also export to something else. And Kasten can do this to NFS, to S3, or in this case, because it's vSphere, I can actually send the persistent storage to Veeam, which we're going to see in a second. Anyways, first of all, I will restore. So I will press local. I could have done exported, just so it's faster. Again, if you really like the command line, you're one of those programming types, you can actually copy this command and script it all you want. I'm pressed for time, and I prefer just to press the easy button. So restore.
Your RTO is 5 minutes, Geoff. Let's go, buddy.
Yeah, that's it. I'm rushing. So I'm pressing restore. There we go. Going back to dashboard, and this will actually show us doing the restore. Okay, we'll let that go. It'll do its thing. And while it's doing that, I just want to go back and show something in the other window. That should be very quick because it's local. But what I want to do is show you the component that went to Veeam. So I showed you the conventional or the legacy Windows. It's an actually AD server I backed up here. But look at this. Nginx and a nice little Kubernetes sign. That is that Nginx backup, which has been exported. Now, when I talked about having everything in one pane, what do I mean? Remember, I did this right click. I have all these options. Well, this is now becoming available as well in the Kubernetes world. I can right click this. Wow. Instant disk discovery, export, restore guest files. Well, why don't we try that? We'll have two restores going on simultaneously. One's happening on my cluster. One's happening on a Windows server, by the way, with Veeam. And we can see which one's faster. This one will take a bit longer probably because the other one should be really quick. Oh, well, there we go. So I want yesterday, Monday, right? And this is just a standard. It's a standard. You see a little penguin there because it's using kind of Linux technology to do this. But what you will see, which will be interesting, it's going to bring up a little window. That could take a few seconds, but it'll show the disk in the container, not a Linux. Well, it is Linux. Of course, containers are based on Linux for the most part, or mostly, but it'll show that one mount. So that is different from a normal Linux restore. Okay, so let's go back now, and I want to see what's happening here. Oh, look, my restore was successful. Also, it's green too, which is always nice because green's comforting. Red's what scares you. You can see a lot of reds when I was testing this because I was having a lot of fun. Okay, so it claims it's restored it. Okay, remember what I had said before? I said Geoff is great, right? Okay. Well, I got in trouble for that, so let's refresh, and guess what? Hi, this is Geoff. So our restore was quick. It worked. Obviously, in a real production environment, things might take longer. You could have databases, whatnot. But it's a very simple and at a glance demonstration. Going back now to this, let's take a few minutes because it's bringing up a helper appliance. I just want to show this part as well.
Yeah. So Geoff, while that's running, right? If I just jump in here real quick, I mean, I guess this is another one of those key defining moments, right? Where it's really nice to see that the technology has moved along with the application requirements, right? And the advancement of the way that application developers now can confidently build in this cloud native space. And from a customer business operational perspective, can I protect these workloads? The answer is yes, right? Can I protect them in an easy to consume manner with a nice, pretty interface? We obviously saw an example of that. Has the backup and data protection software transitioned to the point where it now has the ability from that single pane of glass to be able to show you, what am I doing with my legacy backups? what's the status and how do I manage my kind of existing virtual machines? And do also I have this at a glance opportunity to interact with and manage backup policies that are associated with cloud native workloads? You know, I can think back to the early days of virtualization. The integration hadn't happened yet. You had to use your traditional legacy backup application for the agents. You had to look at a net new solution potentially for the virtual machine scenario. And when we first started this cloud native journey years ago, there was really only snapshots. I could snapshot, but I didn't understand what were all those pieces, parts, and components of a Kubernetes cluster. I didn't understand a namespace. I didn't understand a pod. I didn't understand secrets. There was all these pieces and parts that were missing that were important as well, right? The persistent volume claim information, you know, just as another example. So in this, you know, in this journey that we're walking, you know, I think what we really want to get around is that the confidence level should be pretty good right now for the cloud native application developers that want to be able to help this digital transformation journey, right? We're evolving, we're transforming, and we have data protection that can move right alongside with you to give you that confidence, the ability to recover, the ability to restore, the ability to transform. You know, maybe you deploy in AWS today, and you didn't know a year ago that AWS was going to be your hyperscale public cloud of choice. And inevitably something happens. You have an outage, you have an uncomfortable situation. There's a business decision that gets made that maybe now you want to move a certain portion of workload over to another entity, right? Another hyperscale public cloud, or maybe you want to bring that back on premises because you've decided to run your own self-managed Kubernetes cluster. Yeah. Solutions like this give you that cloud portability and freedom of choice, right?
Exactly. Yeah. And as you've been talking, this has come up and proven exactly what you just said. So you saw before what I was doing in the Kasten window. So this is a Veeam Windows server. So it's mounted that. And as anyone who knows Linux will say, well, wait a minute. Okay, SDA I know from Linux, but where's everything else? Where's, the root file system? Well, there isn't. This is just the persistent storage. So there's my index file. And this will allow me to restore this to the local Veeam server, which I'll do very quickly. And, I had one there already. I tested this. I always test very quickly. Last thing, I just want to prove that if I now go to the C index, which is, there it is, C source. What do I have? I have that's the backup before yesterday where I was really going nuts. Hi, this is Geoff. Geoff is the best and deserves a big raise. Sorry, I'll leave that for the last part.
Yeah, you've got Michael laughing. I see Michael's come back on the stream now. We must be running out of time.
There you go. So he needs a raise there, Tim.
Yeah, for sure.
But I put that in last just in case. I know.
Awesome stuff. I think that's just given me some ideas as well about the persistent volume, bringing that back into Veeam, back on replication, the whole single interface to look after everything. I think there's a hugely powerful message there on there, and thanks very much for the session, guys. I thought it was really useful. There's no questions on there, but hopefully we'll get some comments afterwards as well. But yeah, awesome session. Thanks very much.
Thanks a lot, guys.
Michael, thank you very much. Guys, enjoy the rest of your day. Yep. Appreciate it.
Bye-bye.
Okay, so now we're going to bring Claus into the mix, who's going to be talking more about object storage. So, hey, Claus.
Hi.
Good
day, good evening.
Good stuff. Let me share your screen. There's going to be a bit of inception there, but yeah, if you, I think you're.
Sure. I'll put up my.
Yeah, there we go.
There we go.
Over to you, Claus. I'll let you get started.
Yeah.
I'll come back in
Thank
at
you.
the end there, and if there's any questions, we'll be sure to ask then.
Yeah. I have a section for it. So if my voice is a bit rusty and you can't quite understand what I'm trying to say, then just leave a question at the end, and we'll pick it up there. So yeah, I would like to talk about how to optimize small object storage and how to deal with the problems that typically arise from that. I work at Minio, So, and yeah, let's start by looking at what object stores are in general. So in large terms, it has mostly replaced file systems for cloud native, cloud wide, consistent, concurrent storage. And yeah, it's really been a great innovation in terms of having storage available for stateless services that you're running either in the cloud or in the public cloud, in the private cloud, or in a hybrid cloud. So some of the most typical operations you see is getting data from it, putting data back into the to storage, listing, basically listing the various objects that exist, and then cleaning up, deleting objects. There's also some other features that aren't discussed as much. So one of the features that is very important is logging and immutability of objects. That could be from a legal perspective, that you need to preserve information for a certain period, but it could also be to protect against ransomware attacks, where you basically make it impossible to mutate data within a certain time frame. You have, as part of that, versioning, where you can roll back to previous versions of your objects that you want to read. You have life cycles that typically have things like cleanup of your data, in terms of if you have data that you don't need after a certain time period. It could also be deleting older versions after a certain time period. Things like that to manage your data, don't have it ever growing, and basically having a bill that explodes for you. A lot of people that we are dealing with also find encryption to be really an important part for them, because they need to protect customer data, and they need to comply with various rules and regulations. Finally, replication is also a method used for either geo distribution or simply as a running backup of your data. If you're in the petabyte scale of data, then you don't really have instant backup of anything. So therefore, replication can serve that purpose for you. So yeah, let's talk about scalability and how to deal with scaling object storage. So I tried to lay out three of the things that reduce scalability in a typical, or that can at least reduce it. So you have the scalability, the ability to scale into a huge cluster, and basically what you want is your performance to scale in a linear fashion with the hardware you add. That is an important part. That it's basically the base requirement of scalability. For some people, it's good enough that you simply multiply or keep the performance that you have, but in some cases you also would prefer to get the extra performance that you get from adding more hardware and having more hardware available. Availability in itself is is important, because the more hardware you add, the higher the chance are that some is going to fail, and you need to have consistent failover, and you need to be able to keep operating even if various parts of the setup is having issues. Finally, consistency is sometimes overlooked, but it's also at least when you're as application developer, you need to rely on a certain level of consistency. Basically, what are my guarantees for when an operation completes, that it is effectual and that it's stored on disk and isn't and you don't risk that it is actually not working. So typically, when you look at these, you take these factors and then look into the performance side, which is either throughput, basically how many gigabytes per second can I upload or download or from my cluster. How many objects per second can I retrieve? Basically, yeah, or upload, download. Also, you could run into synchronization bottlenecks, where you run into a limit to how much the cluster can synchronize, and in order to give a consistent view of your data. So just to give an overview of Minio, just so you have an idea of what I'm talking about. So Minio is a S3 compatible object store. It is available for private cloud, so you could run it on your own server. You can run it on public cloud instances. You could also do a hybrid cloud where you run parts on your own hardware and other parts in the cloud. It is erasure coded for high availability. So data is distributed across servers, and that ensures that you have availability. If some data, either a disk or an entire server, goes offline, you still have access to your data. There's no centralized database. Everything is persisted onto the file system, so you don't have to you don't have inconsistency between different layers of a database. You don't have replication going on, so there's no lag or anything. You have the disks as your authority, and there's read after write consistency, which basically means that once you've got a reply, the object is written or deleted or anything like that, then any request following that will see that new state. So let's look at the small object case. So what are we talking about? Typically, when talking about small objects, we're talking about less than 10 megabytes, because the thing is that if you take big objects, gigabytes, then you're pretty much sure that you'll be maxing out your hardware, either your storage, your network, or something like that. With small objects, you stress all, excluding the network. So basically, you're stressing your storage, your CPU, synchronization, all that part of it. In overall terms, we recommend hard splitting disks for large objects and SSDs for small. I think it's pretty obvious why, but on the other hand, it may not always be the hardware you are having to you have available. So yeah, looking at small objects, you have things like range requests, which can also give subsections of bigger files, which is sort of enables you to have smaller sections in a big file. So you upload a big file and you chug out parts of it. And the thing is, it's quite difficult to manage on the client side because you need to know where to look for each section inside the file, so you can build the correct request for that. So when dealing with small objects, we basically need to count IOPS because the way you have to have high availability, you need to have several servers respond to the request, so you need to ask several servers, and that doesn't depend on the object size. So that's why the smaller they are, the bigger that part of the overhead then gets. So you for every small object you have, you will be hitting your physical storage on a number of servers. So there's various ways to cheat this. So you can have in memory parts of your storage. It's quite risky because you risk missing saves if a server crashes, or if the server simply fills up, then you can get into trouble that way. And the thing is, you're just creating a buffer that once that's filled up, then you're basically running into the same problem that you would have otherwise. So let's look at how we do this on Minio. Then we place all objects on a file system. We don't have any special storage layer. We use standard Linux file systems, or even Windows or Mac if you do that. So data is placed into buckets, and you have a path where you place your object, and the storage on the file system simply reflects that. We have an Excel meta file that basically contains information about the object, the size and the checksums, headers, stuff like that. And then due to how S3 objects are split into two parts, we store a file for each part. So what we did is that obviously the overhead of having the parts separately on disk for very small objects, it becomes quite big in terms of just inodes and extra blocks that you use. So we decided for small objects to simply inline the actual object data into the metadata file. So we're able to basically read metadata and return the data by simply opening one file on disk and reading that back. So some of these standard file system limitations also applies for us. So that also means you should create a reasonably separated path for your objects. Sorry. That way you don't have millions of objects in a single folder, because no file system can deal with infinite number of files in a folder in a reasonable way. You also have limitations like block sizes. Typical block sizes are 4K, so any file you store will take at least 4K, and so forth. So and of course, for every file you create, you are using inodes in or from your disk. So that's some of the things we've been dealing with in this. So one of the features we added is tiering, where we allow to offload the data part to secondary storage. We call that warm. So we have you can set up a hot tier where your data lands when it comes in, and then after a while the metadata is kept on the hot tier, but the actual file data is then tiered off to a secondary storage. So you're able to do all the operations on the metadata in a very fast fashion, but you don't have the huge penalty of having to keep all of your data on SSD, for instance, for forever. So other things we've looked into is API improvements that can help you. So there's a little advertised S3 API that is used for snowballs, which is the feature where you can order your data and have it delivered on hard drives. But it also has an API part where you can basically upload a tar file, and it gets extracted onto the destination as it's uploaded. So you're uploading a single file, but it ends up with potentially millions of objects on the remote. So it allows you to upload this many with just a single call. The strain for the server is approximately the same, because you have to store everything as individual objects, but it does allow the upload to take place with just a single call, which is usually preferred. We also added a zip extensions that allow you to list and read files inside zip files on a remote server. They are automatically indexed by the first operation that does it, and it's very performant. So you're basically able to extract a single file from inside a zip file with the same efficiency as opening a regular small object on the server. the files remain as a zip file on your storage. So everything inside it is controlled by this single file, which means you can replace everything atomically. So if you replace the zip file, then you're switching all of the files inside in a single operation. Similar to how the tar file upload requires a custom header, this also requires a custom header, just to be sure it isn't accidentally triggered by a client. So you add a header called x-min extract equals true. You upload your zip file. So we upload restaurants with the date. This is the prefix, and then we upload a zip file. We just call this ID 0 to 1000, and you can then use regular list object operation to list all the files inside this with a single operation, and you can request with get object any file inside the zip file. So yeah, it's quite space efficient, mainly because you don't have the overhead of all the individual objects. It allows ID to value lookup. So if you name your files with the ID of what you're interested in, then you can simply do an ID to value lookup and get the result. Obviously, you upload much faster than you otherwise would. You do it with a single call instead of thousands. It's easy to manage. All operations are done on the object. So sorry. And it's a well-established format. So there's no specialized code needed to create these. You can't do individual file updates inside the zip file. We keep a recommendation of around 10,000 files inside each zip. That's mainly to have the lookup be fast enough so you still serve millions of files per second. It shares metadata. There's no unique metadata per file inside the zip, and it requires some minor client modifications. So yeah. So yeah, for servers, we recommend benchmarking for objects per second to see if you can hit the target that you're needing, and also consider the entire object life for this. We have seen people that have benchmarked, and yet we can upload this many objects per second. Everything is fine. Go ahead. Then they figure out, but there's also we have to update or delete. Cleanup is pretty much as expensive as uploading. So unless you expect your data to live forever, then consider the entire life of the object. IOPS is king, so a write needs to hit disk and requires the physical head in terms of spinning disk to move or the electron rows to activate for SSDs. So there's no way to make physical disks move their heads any faster. So be sure to not have crazy, let's put it that way, expectations on what your storage can do. Provision ahead. You shouldn't provision, so you have to upgrade, keep adding new hardware all the time. It should be something like every second year you should upgrade your storage in terms of capacity, and because otherwise you'll be having to do a lot of management for that. When writing clients, design for big objects. If it's at all possible, then avoid having too many small objects. You're making it much easier for whatever customers of your application there is to create a reasonable performing deployment. The bigger your objects are. Maybe write a little extra if it can avoid you having to search for the information. Use the available tools. There's an S3 select API that allows you to retrieve data from CSV and JSON files based on queries. Can be helpful. The zip files I just showed you, range requests, or maybe the tar uploads, at least to make the upload big, more manageable. Let's put it that way. So yeah, that's what I have. Let's start if there's any questions.
So there's no questions clause, but a great in-depth session around, like, I've learned quite a lot around some of the intricacies around object storage and some of the, more to the point, some of the considerations that you're going to need to really be thinking about when it comes to like designing and architecting that object storage, whether it be for like a stateless workload, but in general, I see a lot of object storage for backup targets as well. And I think some of the considerations are exactly the same, right? Whether they're whatever that workload, whatever that data type is, there's a lot more consideration in there than that I gave it effort to. So
there's always when you get into the details, but yeah, it's there's a lot of important factors to consider when you're because if you're doing it in a public cloud, you're paying for the same operations. So small objects will mean more requests back and forth, and will just make it more expensive. So it's the same issue, and the cost is just going somewhere else. so yeah, that's
exactly that. But amazing session. Thank you very much, Claus. So
sure.
The session will be available on its own as well as part of the whole day or half day event as well. So we'll make sure that we're sharing that socially out there. But yeah, thank you very much, Claus, and hope to see you again soon on another CNDM day. Thank you.
No problem. It was a pleasure.
Awesome. Okay, now just transitioning into a bit of a panel discussion with the evaluator group. So I'm going to bring everyone on here. Hey, Camberley. Hey, Randy. Hey, Janie. I'm just gonna hand it over to you guys. I know we're running about 5-10 minutes after, but I'm super interested to hear your takes, what you're seeing out there, and what that discussion point is around the state of the state, I should say, or the state of the container workplace. So over to you, Camberley, to chair and drive this one. I'll jump back with any questions at the end of the session. So thank you.
Uh-oh.
Camberley, we can't hear you.
Okay. Yeah, Camberley, there's something wrong with your mic. I know.
Camberley, do you want to just jump out and then jump back in again just to see if that helps? And I know it's the Chromium browser that we should be using, although I've never seen anything like that happen before. So
Yeah, it's a Minnie Mouse voice.
I know. It sounded like she'd been sucking on helium.
we went through it yesterday and it was fine, but that always happens, isn't it?
Yeah.
So in fact, let me pop this on just so that we're covered as well. And then when she comes back in, I will bring it back.
Can you hear me?
Yeah, there we go. Perfect.
Yeah, okay.
I didn't need to use the full 5-minute interlude because that's some terrible music. Yeah, okay. So I will drop out. Thanks, Camberley, for refreshing. Hopefully all is good now. But I'll leave you to it.
Okay, great. Well, of course, I'm also having problems with my slides, so we're not going to do those. Okay, we'll head right in. Hey, folks, I'm Kimberly Bates. I'm with Evaluator Group, and I have my Evaluator Group misspelled there. Isn't that wonderful? Okay. Didn't even see that yesterday. I have with me today Randy Kearns, who is our senior strategist with Evaluator Group, and Janae Stoley, who is our consulting analyst with our company. If you don't know us, we are an analyst firm based out of Colorado. We work with both end users and vendors. Some of our end user clients are big, well-known names. If you went up to our website, you'd find those names up there. We are, and those are the folks that we do consulting with. And Randy is our primary person that works with the IT end users. And what we wanted to do today was talk about some of the perspectives that we're getting from these large Fortune 500 companies. So with that, I'm going to kick this off. One of the things that we saw last year when we did our research on the hybrid cloud is that about 68% of the people have in our enterprise companies, those companies that are over 1,000 employees, et cetera, are going into production with containers. They're either already in production or they're about ready to go. And so in this session, what we're going to do is talk about the challenges and the decisions that were being made and why. So I'm going to go back a little bit, and we're going to go through a little bit of memory lane, and then we'll come up to current time. Back in 2020, Randy, you started getting inquiries from our clients. And those were for the most part IT infrastructure people and the data people, not DevOps. They were looking for some help on some decisions they were making and around containers. And usually we're taking, calls on ransomware and data protection and data storage and big, huge, AI systems where you've got data lakes and that kind of thing. But they were calling us about this. What were the issues they were facing at the time?
Well, you could summarize it in saying, for the most part, what is this? But they got surprised. A lot of the applications were coming in from their development team were container-based, and they required a different operational environment. And the development teams had set up their own specific environment. And in most cases, they were very much a erect or set type of thing, required the developer to install, maintain, update, and operate those environments. And so that wouldn't scale for the IT people. So the conversations that they ask about is saying, okay, we understand this is part of the bigger picture IT transformation strategy, and the fact we're going to have to deal with containers, but what's the right answer here? Many of them had been gone down a path at one point, were even trying OpenStack, and that had not worked well for most of them, or had been oversold to a great extent. And so they were very wary of jumping in on something, but yet they had to do something. And so it's all about what should they be doing as things go forward, as they expect to scale very large with the number of applications and the container-based applications that were driving that.
Great, thank you. And so then let's kind of fast forward to this last year, 2021, when Janae came on board to start looking at the container management platforms, aka Tanzu, OpenShift, and SUSE Rancher, those kind of guys. And Janae, the first thing that you did was tap into your entire network of IT executives and executive vendor people that you know, well known in the industry, as you are. And what did they come back to tell you? What did they have to say?
Well, essentially, the sum of it was, we wish we didn't have to do this, but we absolutely do.
And that came from the enterprise executives. Okay.
Exactly. Particularly the enterprise executives who would be charged with making the move to container managed platforms and microservices architecture. And the challenge is that this is not an easy migration. It is probably the most sizable investment and the most disruptive change that they've had to make for those who are old enough since moving applications off the mainframe. And so it's not a change that they looked forward to, but they had come to realize that it was a migration that they absolutely need to make, because the benefits when you get there are so great, and the risk of the business risk if you don't make the move is so high. And the way that was described to me was, and by some very large, very well-heeled companies in our industry, was that, you know, they see that they have new competitors who come to this party with a blank sheet of paper, who can very rapidly bring up the new architecture and then rapidly innovate in the same spaces where they have historically sold, and they can't keep up. And so they see that they absolutely need to move to microservices architecture for innovation, and they absolutely need to move to containers to be able to make the microservices architecture applications work. So.
I think it's, let me amplify on that for a second. You look at it and say, is the motivation for these people saying, well, the developers are developing in containers, so we have to do that? Well, certainly that's true, and that may be the superficial or the first answer you get. But this has got a senior executive view saying this is competitive. Yeah. We have to do this to remain competitive or to get competitive in the environment. So the justification then goes all the way to the top.
Yeah, absolutely.
Yeah, and I've seen that. I mean, I personally hear it when I go home every day, because my husband is on a regular basis. They're pushing out the next set of code for a very large national trucking firm, and this
and when you think about it, absolutely. When you think about it, I mean, my own personal example, I had at one time was responsible for a very large, many million line of code file system, and you know, we could make a development change that took maybe a couple of weeks, and it would still take us 9 months to push out the release, because by the time you ran through the rest of the development cycle, unit test, system test, early release, et cetera, it was 9 months to release any new functionality at all. And that clearly doesn't work in the new agile environment. It doesn't support innovation. You've got to be able to push out new releases constantly. And the only way to do that in a productive way is with microservices and then an underlying container architecture.
Right, and that's where you get into, it's key to the CI/CD development methodology now.
Yep.
And I think people that are watching this already know that, but it's kind of as a good reminder to say that the executives are catching up with where they are.
Yeah, exactly. I mean, I think the message is if you're not moving down the path that you really should be, you cannot, that we've reached a point where you can no longer wait.
So now we are 12, 18 months past those initial discussions. Where are we now? What is the kind of like the world look like in these guys? They're saying, okay, I got to go. We're going. This is the state of the union here on my floor.
So I think that where we are is that people started with test benches and sandboxes and individual efforts and putting it together yourself, as you described in DevOps. And then there were some larger proofs of concept, which were a collaboration between development, operations, platform engineering, and everyone. And now what we've got is, it's the same old story. You know, we always end up with islands of automation. We now have islands of containerization. And in each case, people selected a management platform that worked for what they were trying to do. But now the operations, platform engineering, and security side of the house is looking at this saying, this doesn't work because it's not governable, it's not secure, it's not controllable. I need to establish a standard for all of these deployments. And maybe that doesn't mean a single solution, but it means I have to be thoughtful about selecting a package of container management system that can work for everyone to the greatest extent possible, so that I can manage it, so that we keep it, so that it maintains itself, so that it's secure, and so that I can govern what's going on. And so what I found then was that people wanted to know, what should we be looking for in that container management system standard that we're going to set?
One of the big fears is that they go down the wrong path, or they get somewhere and they just can't scale larger. They can't introduce new things, and so there's a real fear that they'll get on ride the wrong pony here.
Right.
And so that's why this analysis is so important.
Yeah, and I should say, by the way, that the main issue that these customers are all having are not computer system issues. They're human issues. They're the inability to find talent. It's the same talent that the major cloud service providers are hiring to drive cloud native. And so they're competing with very large companies that have very nice career paths for development. They need to, again, develop new processes and culture, just as when we put networking and storage together, just as when we put networking, storage, and processing together. Now we're putting applications together with that all in the same boat. Do you do that with tiger teams? Do you do that with a new organization? They're working their way through all of that. What that means then is, from a platform perspective, they need to establish that container management system so that they can kind of package that away to not worry about it, so they can spend their time and attention on these human issues that really matter. Do you see that as well, Randy?
Absolutely. And they want something, it's terrible to say, they want to be more turnkey.
Yeah.
And Janae can probably talk about, but that turnkey isn't there yet.
Right.
Yeah, it's spread all over the place. And I think what we found, and that's kind of going into the next thing, we are about to launch our container management platform coverage, and that is platforms or services. It's both a managed service as well as your self-managed kind of environment that we looked at. So maybe give me one of the key takeaways. I think you already touched on one of them, Janae, is the people issues. This is a real big people issue. What is another takeaway you have for, in terms of when you looked at the scope of this marketplace, of the offerings that are out there? What did you kind of find?
So I think there's a couple of early things that customers can look at to help with driving down a decision cycle. The first is to decide, do I want to adopt a managed service, as you said, or do I want to adopt a self-managed platform? And along with that, whichever one of those I select, do I want to have the flexibility to change my mind at some later point in time without a huge investment in either, a huge capital investment or an investment in new talent and skills? So, figuring out where do I want to start, and then thinking about what my longer term issues might be is one thing that you need to think about. Then the second thing is that the offerings that are available, one more point on the platforms versus services, many of the providers in this space offer both a platform and a service, but very few of those have the same features, benefits in those two offerings. So if you look at a vendor's service offering, you will not necessarily find the same features or maturity in their platform offering. And in general, the service offerings, by the way, are more mature because this whole thing got started from the cloud service side with Google and Azure and Amazon driving some of the train. So so you just because you decide, okay, I have a very trusted vendor relationship with XYZ vendor, they have a platform and a service, it doesn't matter which one I pick. Yes, it still does. You need to think about where are you going to go long-term as well as short-term. And then the other thing I would say is that there are some common pieces in all these offerings. And so understanding where you're going in terms of what's important to you now and in the future is also important from that perspective. So there are basic offerings that will support cluster at a time management. And then there are advanced offerings that offer many clusters management from a single pane of glass, and understanding for each vendor, how do those advanced offerings plug into the core? In some cases, it's the same product. In other cases, it's an add-on to the product. And you just need to think about, what is my scale out plan going to be? These are not necessarily new issues to any decision that enterprises have to make, but so it's kind of like, well, those are the same things I always worry about, right? But you're thinking about them in terms of scaling the management system as opposed to scaling volumes of data or scaling, the usual things we worry about.
So Randy, you've been involved with some tenders or RFPs in this area. Maybe you can talk a little bit about what you've seen with those, that when you've advised some of the clients.
Well, there's let me bring up a couple other dynamics here. Rarely do people get a complete clean sheet of paper on this. That's what, unfortunately, most of us tend to talk about when it comes to containers, because it is so new, so different, and everything. So one of the big things from customers is they talk about, Janae brought up the personnel issue, absolutely true, but they also are saying, I've got to insert this into my existing environment, my operational environment I have today. And creating a brand new operational environment is not only difficult, it's risky, in that you can do things that may not be done correctly, have problems, may have recovery issues after disasters. The business continuity factors have to come into play. And so bringing this new in, the biggest things they talk about is, how do I make this work in my existing environment? What most do is they look at it and start up somewhat independently. And I think Janae talked about POCs and stuff. I actually move it beyond POC, and they put in what we used to call a pilot program. And a pilot program puts this into place and saying, this is what I'm going to start with. I know I'm going to grow it. And they'll start that relatively modestly and independently. But at some point, they'd like to see how to combine the two environments. Many of them are virtual machine-based operations, and it's somewhat of an anathema to the way it works with the containers and the designs there. And so they don't necessarily see a direction where it's not handled as an exception. We just don't have good answers. So the questions come in, how can I do this? And right now there just aren't any good answers.
Right. And that's one of the things that we looked at as we were going through and looking at some rankings that we have. We will be publishing who's the top dogs in certain areas with the research that we're putting out. And in there, we found that, or you found, I didn't find, Janae and Randy working on this stuff, is that as with typical all technologies, one size does not fit all. And so we ended up having to slice the data a couple more ways and start looking at business drivers. And one of those business drivers was something called container forward decision. Janae, can you comment on that? And then I'm going to go to Randy on the other one.
Yeah, sure. So yeah, as you said, what we discovered is that as customers prioritize their requirements, we asked them what are the key things they needed in a solution, and those core criteria were pretty common, and no one would be very surprised by them. They were, 10 or in some cases 11 criteria that people said, these are the things I'm going to look at. But they put very different weightings on different criteria depending on what their other biggest business problem was at the time they're making the decision. So, as we've been talking about, one of those core issues is and Randy mentioned this, is, how does this merge into what I already have today? And if someone had a very strong need to continue to provide very high quality of service for their virtual machine environment, they had a different view of what they needed their container management system to have in it than if they were getting huge pressure from upper management on this digital innovation front, and they really need to innovate as quickly as possible. And then, of course, we had people also who were trying to, while doing container migration, who were trying to rapidly innovate a new customer experience on top of a major application on their data platform. And that developed a separate set of weightings. And so the one where the customer was getting driven the fastest toward innovation ended up being this one we call customer or container forward. They need to get to a container microservices architecture as quickly as possible in order to address the demands of the business. And so they tend to weight more heavily in that pure container model of really being able to scale in a very manageable way, of having a very integrated offering that integrates the microservices development tools in very well. In some cases, the ability to also integrate prepackaged offerings from the container management vendor around being able to bring in stateful applications as an example. And they were very focused on scaling out security and governance features. So those were very heavy criteria for these container forward people who were worried about, how do I get to containers as quickly as possible while still managing to separately manage my virtual machine environment.
So I'm going to shift topics. This is kind of our last topical area, probably our last major question here. Randy, with this containers, data management changes, that could be an entirely another half an hour discussion or longer than that. How do the information management people shift and change to adopt to this new world?
Boy, that's if we knew that one, we would make a lot of money.
Yeah. Good question.
No, it's really been interesting to watch this develop in certain companies. A lot of companies tried to equate their use of a backup catalog to be data management, and that's one starting point, but it's not sufficient. And unfortunately, that's what we're seeing right now. As we start to see people understand that it's not your everyday backup like we had before, because the container environments are quite a bit different. And there's all these other things to be able to achieve the same state of operation when you recover data, because you have to save things like secrets files and configurations and know what other microservices and containers are in operation. It's just a lot more to do. So once they achieve that, then I think they'll get around to addressing the data management part of that. And right now, I don't think anybody's effectively even discussed how to get there. I think you're going to see the backup people go after it from the standpoint of, hey, I've got the catalog, that's all you need. Whereas it's a lot more than that. And it's an opportunity for some independent companies now to start to look at this and say, what's the big picture? And it's not limited just to file systems, which a lot of them only seem to focus on, even though that's the majority of the data. It's a lot more complicated than that. So I don't think we've scratched the surface on what it's going to mean for data management in a container world yet. Yeah,
it's going to be a long haul. This is, as we've talked about, this is a very slow moving technology because it's getting moving from one, it's a development cycle, right? It's not.
There's great opportunities here.
Yes.
Great opportunities. And one of the interesting things talking about it with a lot of the end user clients is, remember I made a comment about a clean sheet of paper. Most of them actually look at their deployment, their initial real deployment, if you will, not something adopted from a development group, are going to be new purchases. And so people selling hardware and software, this is all new sales. And it doesn't displace existing sales. So it's huge opportunity. So vendor companies are going to be really focused on this from an economic standpoint. The issue is, from a customer standpoint, they need to understand what the customer needs are. And that's the thing Janae's been focusing on, trying to figure out what's really necessary here, and then provide the right solutions for them, not just the same old stuff that we've had before.
Yeah, that's true.
Well, thank you guys. And I'm going to wrap it up here. I'm going to put one plug in. We have coming up in June, 13th through the 15th. If you want to come to Colorado, we have our two and a half day class. And this is a snippet of what you might get. And we will be talking in depth about all the products around in the container world, both data protection, data storage, container management platforms, converged systems, you name it, it's going to be in there. We'd love to have you. If you want to see anything about that, just go up to evaluatorgroup.com, and there's information on education and that kind of stuff up there. We'd love to see you here. Thank you. And Michael, thank you for inviting us. We appreciate you bringing us on. And you see Janae and Randy sitting in the same room here. The reason that is going on is because Janae's internet provider informed her yesterday they were shutting off her internet for like 6 hours.
But I also always look for an excuse to come to Randy's. So
always got to have that contingency plan, right?
Yeah, absolutely.
Starbucks. There we are.
Yeah.
Thank you.
Awesome panel. Great stuff. And can't wait to see you in the next CNDM and what we're doing there. So yeah, thanks very much for bringing such a topical bit of content to the channel.
Great.
Terrific.
Thank you.
Thanks, Michael.
Okay, so we're just going to take a couple of minutes break now. I'm just waiting for Troy and Audrey to come on. So I'm just going to hit a bit of an interlude here, and then when they're here, we'll jump on with the last session of the day. Okay, that's enough of that cheesy music. Let's get into it. I'm going to invite Audrey and Troy into the chat. Thank you very much for providing the last session of the event. I think it'll be super interesting to hear what you guys are up to as well. Are you sharing any slides, Audrey?
Yes, let me go ahead and share my slides. Why is it not sharing? Give me one moment here. Screen.
No worries. While that's coming up, I think the topic of data science is an interesting one and something I know nothing about. But obviously, from a CNDM point of view, looking at the pillar from anything data to anything storage and everything in between, this is definitely one of those areas that we want to share and shout about within the community. Okay, so there's the slides. Let me know, Troy, if there's anything you need to hand over later on, but I'll be sat there just watching for questions. And once you're finished, I'll jump back in when you're finished. But awesome. Thanks for joining.
Thank you.
No problem. I guess we should go live. Are we live?
We
Should
are
start
live.
this?
Yeah, go right ahead.
Okay, awesome. Well, for that brief pause, welcome. My name is Audrey Resnick, and I'm here with Troy Nelson. We are from Red Hat, and today we would like to talk to you about data science as a managed service on Red Hat OpenShift. So first, we're going to introduce ourselves. I've already told you my name, Audrey. I have been, I guess, a full stack developer for the last 20 years within data science, probably for as long as that, even though they didn't call it data science in that time, but officially data science in the last 6 years. And I'm working on a product called Red Hat OpenShift Managed Services. And I'll hand it over to Troy.
Yeah, I am a software data engineer. I am a recent graduate out of UC Berkeley. But yeah, data science is a great field, and our platform roads is a great option, but very new to the Red Hat team.
Okay, so let's take a look at what we're going to talk about today. What we'll look at is a model's role in an intelligent application. We'll look at what are managed services and particularly who uses them. And you'll be surprised, it's not only data scientists, but a lot of other folks. We'll take a look at what managed services have to do with model delivery. We'll also take a look at where you can find managed services. And then Troy is going to give us a fabulous demo at the end of using Red Hat OpenShift Data Science platform and its managed services. So let me jump right on into a model's role in intelligent applications. Our discussion kind of begins with intelligent applications. In fact, that when you look at an intelligent application, it just is not one small deployed thing. It really is an entire distributed system in and itself with a lot of moving parts that are tied together in various ways. So if you take a look at the diagram that I have, I mean, you'll see the model code there in the center, but by surrounding it, you'd have things like data verification, data collection, configuration, feature extraction, all the way to serving infrastructure and monitoring. So because the data scientist model is just one small part of this large distributed system, when you start building a model, you need to think about how the model is going to interact with everything in this distributed system. So for example, how do you connect to a data source and obtain and curate the data that you want to use for your model? You could go ahead and build your own code and application to do this, but it is a lot easier to use an existing service. So with that, we're going to jump in and take a look at what a managed service is and how they're used by different personas in the model development lifecycle. When we take a look at the model development lifecycle, and I want to bring your attention to the green boxes, we have to take a look at the steps in the model lifecycle and also link them to personas that are associated with them. So when we take a look at setting goals, we're going to associate that pretty much with everybody who's going to be developing the product, but mainly the business leadership that are defining the goals and setting the metrics. We move on to gathering and preparing data, where we bring our data engineers in. And then we look at developing a model, where we're going to bring our data scientists in. We look at deploying the models in an application, where we bring a little bit of the data scientists, but more of our app developers or ML ops engineers. And then for model monitoring and management, again, we can bring in our data scientists and app developers or ML engineers. But I also want you to take a look at the very bottom. We have IT operations involved in all of that. Now, each of these steps could have a set of services which would help that persona within that step do their work. So let's dive in further into each step and determine what services would be required to create and deploy a model which would be part of this overall intelligent application. I'm going to move away from setting the goals and look at gathering and preparing the data. Data engineers are going to be working on gathering and preparing the data, and this could be done by a service to make it ready for data scientists to develop their machine learning models. So when they're gathering and preparing the data, they are looking at data storage, they're looking at data exploration, data prep, stream processing. When that data gets handed over to the data scientist and the data scientist starts developing the model, they're going to probably use some sort of integrated development environment or IDE. So which IDE should they use? Can Python developers or data scientists create and use a reusable and recreatable IDE environment? This could possibly be a service with various machine learning notebooks or libraries and packages that they would want to use. Once they've gone ahead and developed the model, they're going to deploy the model within an application. So this is where the machine learning models are going to start inferencing or making predictions based on the new data that they would have seen that we would have brought in earlier. Could we use a ready-made application that would allow us to deploy and monitor these models? So these are all really good questions. We have all of these steps and all of these things that different personas need to do. And as with any data scientist or machine learning engineer, it would be really great to have these ready-made services in each of these steps to use, but without the hassle of trying to incorporate them into your own platform, managing licensing and support. At Red Hat, we've created a data sciences platform with these very services or managed services that we're talking about, except that you're not on your own to find support for the managed services that we offer. So let's take a look at what this platform looks like. To help everybody gain context to where they are, I've kept the steps that we were talking about before, the gather, preparing data, developing the model, integrating the models, and model monitoring and management. And I'm going to build this infrastructure from the bottom up. So at the very bottom, you see the infrastructure, which is the Red Hat Managed Cloud Platform. And this hybrid cloud platform should offer a very consistent experience across either on-prem, public clouds, edge locations, and will be efficiently managed by your IT operations. On the very bottom area, we have the platform being provided either by Red Hat OpenShift Dedicated or by Red Hat OpenShift service on Amazon Web Services. And initially for us, AWS is the public cloud for the launch of this platform. And we determined that our platform needed to be supported on a self-service hybrid multi-cloud platform that would empower anybody working on it, such as the data scientists, data engineers, and software developers to be very agile and collaborative. And that's throughout the whole process without depending too much on IT operations for individual tasks. So if you need more memory, more CPU for a particular project that you're working on and building your container, you should be able to have that self-service capability instead of writing up an IT request ticket. And this hybrid cloud platform should have integrations with hardware accelerators, for example, GPUs, to help speed up your machine learning model development and inferencing tasks. And finally, this hybrid cloud platform should offer a consistent experience across on-premises, public clouds, edge locations, and again, be efficiently managed by IT operations. Let's take a look at the next layer, which we bring in our own Red Hat managed cloud services. So we provide our own core Red Hat OpenShift data science offering. In this case, it is called the Red Hat OpenShift Data Science Platform. And you have the ability to use Jupyter notebooks that would have TensorFlow, PyTorch, and various other images that you could pull into a Jupyter Lab environment to do your work in. And this also ties in, this Red Hat OpenShift Data Science Platform. We affectionately call it ROADS, so you might hear that acronym slip out when Troy and I talk. It also ties in with other optional cloud services like Red Hat OpenShift Streams for Apache Kafka. That's going ahead to gather and prepare your data. And our own OpenShift API management service, which would help you with the model monitoring and management. So again, an example that we would have within our Red Hat OpenShift Data Science platform, other than being something that you could use, we have a managed service in there that is Jupyter Hub and allows you to create multiple Jupyter notebooks for your experimentation. Let's go on to the next layer. And this is what we call independent service vendors or ISV managed cloud services. So for our partners, we include as a service software partners like Starburst and Anaconda. So Starburst is a fully managed service that you can use to access your data using Trino and an MPP SQL engine. So you have very fast access and flexible management of your data. So here, if you didn't want to use Apache Streams, you could use this other managed service provided by another vendor. You could go ahead and create your Jupyter notebook to help you with your model construction, either using Rhodes or the Red Hat OpenShift Data Science platform, or you could use what Anaconda has available. They may have some ready models that you might want to use. So let's go ahead into the next layer. And this is what we call our customer managed ISV or independent service vendor services. And they're going to add software partner offerings like Intel OpenVINO. So once you've gone ahead and gathered and prepared your data, say again with Starburst Galaxy, developed your model in Red Hat OpenShift Data Science, you might want to go ahead and, integrate your models in application development and deploy them. So you could use Intel OpenVINO for that. Now, the work doesn't stop when your model is deployed. You have to continuously monitor and manage the machine learning models in production to make sure they are making the right predictions. And with that, you can use Red Hat OpenShift API management to help manage any of the APIs that you've created. What we want you to get out of all of this is a platform developed for the data scientists in mind, but also the data engineers, the ML ops folks that work with you, and of course, IT operations as a whole, that will allow you to easily go in and create and deploy your model with the benefit of using managed services that we help manage for you, so that you don't have to worry about getting everything into one environment, and that people can then be more successful in working agilely together. Now, one of the benefits or largest benefits that we have as Red Hat is that we have a large partner ecosystem. Now, I only mentioned a couple of the partners in the previous platform, and as a new release, we've only pulled in a few of our partners into that platform, but we have a large ecosystem that you can choose from, whether you're looking at something in data processing or databases, hardware acceleration, data governance and security, or even the AI ML lifecycle itself. You have the option to choose from a number of open source, or I should say Fortune 500 companies as well that are in the sphere. In addition, Red Hat and our hardware partners have also developed reference architectures and benchmark machine learning workloads onto our OpenShift platform to ensure that the services that we offer you will help you build very good models that you're going to be able to deploy efficiently. And with that, I'm going to hand everything over to Troy. Before I hand it over to Troy, he is going to demo this Red Hat OpenShift Data Science platform. And again, we mentioned that it is going to be running from within Red Hat OpenShift Dedicated, which sits on top of AWS. So that's just to give you context of where he's going to be launching this application from. And he will be talking a bit about gathering and preparing data and developing a model and then deploying it. So I am going to let Troy take control of the screen.
All right. So we are hopping right into Red Hat OpenShift Dedicated, as Audrey just mentioned, and we are going to go through a notebook, some notebooks that we have within a text-to-speech demo workshop. Within Red Hat OpenShift Dedicated, we have access to all of our projects. And within these projects, they have all of our deployments. If we look inside, we can see a pre-built application that has been deployed and is available as an API endpoint at a service port, and has the availability to send requests and get predictions. And if it was a text-to-speech model, get text from, get speech as well from. But if we go up to our app menu icon, we can hop into Red Hat OpenShift Data Science, which takes us to our currently enabled applications. So these are the currently installed and usable applications, but there's also the Explore tab with additional services that we offer that are not currently installed. And lastly, on these pages, we have resources. So these are tutorials, documentation, and other material to help you get started either with roads, with some of these services, or doing things like model deployment and model development. So what we're going to be using is the Service Jupyter Hub. And if we go ahead and launch the application, we'll be brought into an option to select the notebook images that Audrey mentioned. And we have several standard images on the left here. We have PyTorch, TensorFlow, even standard data signs. And if we click on the question mark, we can see packages included. Standard Python packages, matplotlib, pandas, numpy, things that will be pre-installed and ready to use. For this specific workshop, we are not able to use the PyTorch notebook. The image for PyTorch does not include audio functionality. So we can create a custom image to include our TTS package and the system requirements and have that pre-installed and ready for us to use. There's a few more selections before we start our server. The container size, which allows us to increase the capacity and CPUs that we're using. And lastly, the environment variables, which in this case, we are specifying AWS access keys in order to take from our S3 bucket, which holds our data set. Our data set for this workshop is an LJ speech data set, which has recordings from a single speaker from a book manuscripts. And so we can jump into this repo and get started and take a look at that data set. When we come into Jupyter Hub, we will come in with all of our projects here on the left. It's very easy to create a new one as well. If you have a Git repository, you can select clone a repository and get started with a fresh clone. We are going to use our text-to-speech repository, which has all of our folders and Python notebooks available to us. We have models and configs stored away. We have utilities, as well as separate folders for our phonemes, our data set, as well as the output. So like to keep things organized within our repository and these workshops. But if we start with the getting started here, this is a great introduction to Jupyter Notebooks. It goes over things like how we define functions and how cells work within the notebooks. And so if you're looking into this workshop, that's a great place to get started if you do not know Jupyter Notebooks. But we will continue on to our data exploration. To start off, we're going to import some of the required utilities. These come from our config folders as well as some of our utils like text cleaners. We also have some other Python imports and pip installs to make sure everything is available. The S3 bucket I mentioned is here, which we are able to download from the Roads pilot bucket. And this is our function to go into our dataset folder and download all of the WAV files required. And they are stored here in the LJ Speech folder. You can see the metadata CSV, which is important, as well as the waves folder, which all of the data set is stored into. So to get started looking at our data set, we're going to define some configuration. As you can see, we have our name, LJ Speech, where it's stored, and the metadata. We have a model configuration here. This will be used in the next notebook as well, and I'll go into it then. However, this is important for the tokenizer in order to get phonemes, which we'll talk about right here. We can see the configuration has 13,000 files. We are in English, and some of the utilities we're using, the phoneme cleaners, that all comes from our imports. So if we take a look at what our data is and what one of these WAV files sounds like.
Printing in the only sense with which we are at present concerned, differs from most, if not from all, the arts and crafts represented in the exhibition. Printing, in the only sense.
Hopefully you can hear that all right. This down below is actually the printed out version of that output. So this is the phonemes that is associated. And if I play it again, you may be able to follow a little along and maybe translate some of it and tell.
Sense with which we are at present concerned differs from most, if not from all, the arts and crafts represented in the exhibition.
But continuing on, taking a deeper look at these phonemes, we can see that there are 40 phonemes in this data set that is an expansion upon the alphabet we are used to, and we have plenty of data to take a look at to see some of the more unique cases, the things we are not seeing. We see punctuation, J's, as well as some more unique letters, including theta. And if we take a look at the entire picture of all these phonemes, you can see the breakdown is massively in some of the more common letters here, while plenty of these lesser known, more unique, and split up sounds are characterized. So phonemes are a part of phonetics, which is a part of linguistics. And the goal is to characterize all sounds that humans can make or perceive. So it is a wide array of descriptors and very specific into which emphasis you're using and so on. So now that we've understand this data set, we can hop into model development where we're going to use that data to train our own model. So yet again, we're going to do our imports and configuration setup. This time we can take a look and see we have some of the parameters to define how large of a model we would like. We import the basic Glow TTS configuration, which includes many more parameters that we could specify, but it's great that they have it predefined for a working model. But we're all set to start training the model. We have to use our configuration to set up an audio processor, our tokenizer, and then lastly, a formatter. And with our LJ speech dataset, we're going to define an LJ speech formatter just so that our dictionary is properly set up for our trainer to use for the training data. You can see the formatter is included in our train test split. Our model includes the configuration and tokenizer. And last but not least, the trainer is set up, including all of its parameters that we could mess with as well. There are plenty of parameters in here, though, so model is plenty big. And for the magic, we can finally fit that model using the trainer, and we will get our step through and our epochs, and lastly, our outputted model when this is ran. And this model could then be used to output speech. You can use the terminal or functions to output speech with that model. Additionally, there are pre-trained models like the Glow TTS model that you can use. And so once we have a fully trained model, we can give it text and have it create output. So if we want to take a look at what we can output, let's take a listen.
My sprinkler goes like this and comes back like my spring.
Hopefully you can hear that all right. But yeah, that's fun stuff. But once we have our model fully trained, these last two notebooks shortly talk about how to deploy that model to an API endpoint using Flask, and then test it and send it text to be able to then output a WAV file and play that WAV file for whatever application or service you are looking for. And once that model is fully prepared and within a proper repo, you can come back to our Red Hat OpenShift dedicated, which very similar to this application, could be deployed and very conveniently monitored and managed using this UI, where you could view it at a service port, at a website, whatever best option is available to you. But that just about concludes our model development and training and this notebook. So I appreciate the following along, and I hope that you guys can learn something and get something out of this. But I'll stop sharing and thank you.
Yeah, and I'll just go ahead and share my screen one last time. And just thank you for your time, and let you know that if you are interested in taking a look at Rhodes, you can try it for free. You can go to https://developers.redhat.com products, Red Hat OpenShift Data Science. We have a number of tutorials there as well. Troy's tutorial will not be there yet. It will be upcoming, so keep a lookout for that. But if you're interested in natural language processing, image detection, or I should say object detection, or just learning how to use a PyTorch or TensorFlow model, or even getting ready to jump into Jupyter Notebooks, we have it all there in various learning paths. So we would like to thank you for your time. And if there are any questions, we will answer questions.
I don't know about the stream and any questions there, but I have a lot of questions to ask about this. The first one from my point of view is how much or what needs to be backed up, and do you have any? How often does the terminology around backing up any of this data comes up? Like, we've found from a Kasten point of view that we're speaking to a lot more data scientists that have that requirement to protect workloads, and it's not the protection of the test data per se. It's actually more of the algorithm that's being protected. Is that something you like? Do you hear that? What you're doing? Like, how often do you hear about backup?
Yeah, so we have some clients where algorithms are very near and dear to their hearts. Really, at the end of the day, when you create one of these applications, everything is tied up within a container, and it's very secure. There is security involved. When they're working in the notebook environment or the Jupyter lab with the notebooks that Troy was demoing, they're going to be saving their stuff in a Git repository. So it's up to them if they've made their Git repository public or private. Hopefully they've made it private if they're very concerned about their algorithms. Other than that, you can rest assured that we have had a lot of people using the OpenShift environment, and they have found it very, very secure.
Yeah, awesome. Yeah, I've still got loads of questions around that data management. But so there was no questions on there, but awesome session, super insightful into the world of data science and in particular around what you guys are doing from a Red Hat OpenShift point of view. Thanks so much for submitting the talk. I'm sure we'll see you again on another CNDM day in the not too distant future. If there are any questions after the fact to any of the sessions that we've seen today, just drop them down into the YouTube comments, and I'll be sure to speak to the presenters, share that around so that we can get you the answers to that. But yeah, with that, Audrey, Troy, awesome session. Thank you very much. Yeah, brilliant stuff.
Thank you for having us.
Yes, thank you.
Awesome. So that about wraps us up for the event. If you have been here, either from a live point of view or whether you're catching up on demand afterwards, thanks for watching. Just a bit of feedback from the community side of things is, let us know if these are useful sessions, whether that's in one of the particular sessions that you watch or whether it's this longer form. Let us know what works or what you want to see. We felt that 30-minute sessions was a good way of being able to get stories across, tell the tales that we want to tell. But I'm also we're open to other formats, whether it's the panel discussion, which we've been very heavily promoting from a CNDM day point of view, or whether it's 15-minute lightning talks, which we've done as well in the past. So let us know what works. But also that call for papers is still available. If you've got a good story or a tale to tell, then be sure to drop that into the CFP.